So welcome back, guys. This is Madhav PVL, and today we are going to discuss about the basic introduction of a computer organization and architecture, which is from course outcome one. So now, basically, what is meant by what is meant by a computer system and its submodules? So they are electrical signals, analog and digital. The analog signals are continuous in nature, and digital signals are discrete in nature. Electronic device that works with continuous signals is known as an analog device, and the electronic device that works with a discrete signals is known as a digital device. We use 0 to represent low and 1 to represent high. So basically, we need to just remember one thing. So analog is nothing but it will have only a single logic, one logic, or a one code. So analog is nothing but it will just contain only one code, where digital consists of so many codes. So that we can say it will just work. It will just work depending upon that particular circumstances. So digital device is a bit different from analog device. So analog device gives the accurate measure of the things, and digital device sometimes may differ with analog device. So here 0 is representing the low signal and 1 is representing the high signal. So this is uh, some of the things which we need to learn. And computer architecture refers to those parameters of a computer system that are visible to a programmer, or those parameters that have a direct impact on the logical execution of a program. Examples of a computer attribute include the instruction set, the number of bits used to represent the different data types, IO mechanisms, and techniques for addressing memory. So this is nothing but it is just explaining about the computer architecture. So the computer architecture is nothing but the way a computer is made, the way IO mechanism way is made, or the way the techniques for addressing memory is made. So the ways in which the computer works on a particular principle, then those principles are built from this computer architecture. So that is the basic of a computer architecture, which is visible through to a programmer, and which are the parameters which will just directly impact on the logical execution of a program. So that is a basic definition of a computer architecture. Computer organization refers to the operational units and their interconnections that realize the architectural specifications. Examples of organization attributes include those hardware details transparent to the programmer, such as control signals, interfaces between the computer and peripherals, and the memory technology used. So basically, most of the details of a system or a device will not be revealed to the outside, that is public, because some of the details will be transparent to the programmer, such that they will not make any changes in some softwares or in some devices. So such as control signals and interfaces, and then memory technology which is used. So those will not be so those will not be announced directly to this programmer. So some of the things will be transparent. So computer organization refers to the operational units and interconnections that realize the architectural specifications. So that is not much important. And then here comes the state diagram. So state diagram is nothing but the representation of a process. So the representation of a particular process is done with the help of this state diagram. So the state diagram represents the finite state machine. So let us just discuss about finite state machine in the upcoming slides. So finite state machine is nothing but a particular process. So the circles represents the machine states. So they labeled with a binary encoded number or reflecting state. Directed arc represents the transitions labeled with an input or output for the state transition. So if the input is nothing but if it is containing two circles, then it is just transferring the state. So it is the main thing which is just transferring the data. So here the data will come like A and B, and then it will just bring back the output as B and Q. So the state which is represented with the two circles is the first basic input, and then one circle is called as the receiver. So this is sender and this is receiver. So this is a continuous process or a single process. It depends upon the return values and this so on so many factors. So this is about state diagram. And then state diagram, finite state machine can be in one state at a time. So as we can see, it will be either in the starting state or it will be in the ending state. So finite state machine can be only in a one state at a time. Therefore, only in one state or in one circle at a time. Straight transitions are followed only on a clock cycles, that is synchronous transitions. And Mealy and Mori models of finite state machine. A sequential circuits as a inputs, outputs, and internal states. There are two models of sequential circuits, Mealy and Mori model. They're different only in the way the output is generated. In the Mealy model, the output is function of both the present state and the input. So basically, sequential circuit is nothing but which will come from top to down approach. So the circuits which will come from top to down approach are known as the sequential circuits. So here we are discussing about two models. They are Mealy and Mori model. So basically, they differ in the way the output is generated. So the Mealy model, the output will depends upon both present state and the input. As we can see now, in the Mealy machine, the input will just come into this logical circuit and then registers. So and then the output will be the combination of the both raw input and then that of the logical input. So it will only just depend upon this present input and then present logical input. So it will just give the output, but it is just different, right? So let me just bring back to this another slide. So in Mealy model, the output is a function of both the present state and the input. In Mealy model, the present state is nothing but the normal input. So here this is known as a present state. And then the next one is present state and the input. And the input is nothing but it will just come through this logical end, right? So these both will depends upon this Mealy machine's output. And then this Mori machine is just will depends upon this logical input through this output, and then it will just give the output normally. So it will just depend upon this logical input only and along with the state register. So this is the difference between the Mealy and Mori machines. So now let us just discuss about this von Neumann architecture. So the von Neumann architecture looks like a very big name, but it's just a design of a computer. So the computer consists of four main subsystems. They are memory, arithmetic and logical unit, and then control unit, and then input output systems. So these names are similar if we try to just remember in a simple way. So the program is stored in a memory during execution. Program instructions are executed sequentially. As I said before, sequentially is nothing but the top to down approach. So the computer consists of these four main subsystems, that is memory, arithmetic and logical unit, control unit, and input output subsystems. So what is meant by this? So we can just discuss this in this if we know this four things basically. So the memory is nothing but the space where we can just store the data which is required for the input and the signals or the registers which were required during the process, and then the output will also store in the same memory. So the memory plays a crucial role. And then arithmetic and logical unit is nothing but it performs all the arithmetic and logical operations with the help of the memory and control unit. So control unit is nothing but it will be in the CPU. It performs, sorry, it controls all the operations and it will just gives the signals for which time which operation should be controlled and at what time what should be completed. So the use of control unit is this, and the input output system is nothing but the data which is given and the data which is taken. So these both will be controlled with the help of this input output system. So the program is stored in this memory during execution. Program instructions are executed sequentially. So now let us just discuss about this with a diagram. So memory. So the memory is nothing but, as I said before, so the input and then processing data and then registers and then flags and then output. So all these things combinedly stores in this memory. So the things in this memory will just pass through this CPU. So in this CPU, we will have two things, that is control unit and then arithmetic and logical unit. So control unit is nothing but, as I said before, it controls this whole operations, that is all this memory input output. So it will just control all these operations. And then ALU is nothing but it will just perform all the arithmetic and logical operations. And finally, the input output is nothing but from input, it will just reach the processor. And after reaching the control unit will decide the arithmetic and logical unit to perform the operation. And again, the data will come to control unit, and then the data will be stored to this memory. And from this memory, it will just bring back the whole thing to the output. So let me just erase all these things and let me just finally give this good explanation. So from input, we will just receive some data and it will just go to control unit, and then it will just reach to arithmetic and logical unit, and then again it reaches to control unit, and again the output will be stored in the memory, and from the memory the output will be bring back to this output screen, and finally it will communicate to this outside world with the help of the screen or printers or whatever it may be. So memory will store the data and program. So control unit will execute the program. So ALU will perform the arithmetic and logical operations. And then finally the output will just give the input and get the output. So ALU, let us just discuss in the upcoming videos. So this is the basics of computer organization and architecture. Thank you for listening.